I'd like to do a problem off of page 118 in our textbook, number 21 here about blood pressure. A sample of blood pressure measurements is taken from dataset 1 body data in Appendix B, and those values with units of millimeters of mercury are listed below. The values are matched so that 10 subjects each have a systolic and diastolic measurement. So we have 10 blood pressures. And what we're asked to do here is to find the coefficient of variation of the two samples and then compare the variation. So note here the same data was used in section 3.1, which tells me in section 3.1 we were asked about measures of center. So I kind of want to just talk about measures of center, measures of variation, and answer this question in this video. First job is to put the data into our graphing calculator, so I'm going to clear out list 1 and then enter in the systolic blood pressures. And now the diastolic blood pressures. Okay, so let's pull up the 1var stats because that's where a lot of the things we'll want to talk about are. So here for L1, the list of systolic blood pressures, I have some summary statistics. So the systolic blood pressure. The mean, 127.6 millimeters of mercury. All right, always want to use units, and here I'm going to follow our round-off rule where we carry one more decimal place than in the original data. I'm going to go and write down a median. All right, looking through the data, I don't see any repeating data values, so there's no mode. And we could calculate a mid-range, but it doesn't do as good of a job. So I'm just going to let our measures of center here be the mean and the median. We'll repeat that in a moment for the diastolic blood pressure. Let's write down the standard deviation. 18.6 millimeters of mercury. If I wanted a variance, I'd need to square that, and I want to square just a few more decimal places here, so I'm going to write that out for later. And then we could calculate the range, which is going to be the max minus the min. All right, so let's calculate that variance. 18.614121201, more decimal places than anyone could possibly need, and here I have 346.5 millimeters of mercury squared. The range 158 minus 96, 62 millimeters of mercury. Literally telling me that the entire span of the data lies in those 62 millimeters of mercury, the lowest to the highest, 62 millimeters long. All right, so those are my measures of center and measures of variation. This problem really is asking me, though, to calculate the coefficient of variation. So I take my sample standard deviation, I divide it by the sample mean, and then I want to write that as a percentage. Get 14.6%. Well, now let's look at those diastolic blood pressures. Those were in list 2. And here are the summary statistics. 73.6 millimeters of mercury. The median, 75. So I can see the measures of center are very different for these, right? Your systolic blood pressure is higher on average than your diastolic blood pressure. Well, we don't need to know this for a stats class, but this blood pressure is when your heart squeezes, and this one's when it's relaxing. Standard deviation, 12.5 millimeters of mercury. I want to write down a few more decimal places here to square that in a minute. And I want to calculate the range, which will be 90 minus 52. All right. 12.46506.229 squared. Again, way more decimal places than I need to worry about, but 155.4 millimeters of mercury squared. Then 90 minus 52, we just get 38. But again, we're really asked to compare variation, so I want to know the coefficient of variation. Even though I have similar units, these come from different populations. So before I compare variation, I need to make this calculation. And I get 16, well, closer to 17% when I round to 1 decimal place. So looking at these coefficients of variation, I would think that diastolic has more variation, not by a lot, but by enough to mention.